Hi everyone, I'm Jigger. In this series, I will walk you step by step through building a block from scratch. Episode 1. Let's start simple with a classic counter example using a traditional set state approach to update the UI. We will create a counter page with an integer count to track the value. The layout is similar to previous example, so I will fast forward a bit. I will upload all the code to GitHub. The link will be in the video description if you are interested. We add two buttons. When clicked, they update the count using setState. Let's run the app and check the result. It works as expected. Episode 2. Now let's refactor the UI update logic use string. Before we dive in, let's review what generic and string are. Generic allow you define class, interface, or function without specifying a concrete data type up front, making your code more flexible. For example, let's say we write a int block to print integer. Later, we want to print strings, so we write a string block. That works, but it's not elegant. Instead, we can write a single block where T stands for a generic tag. Then we create a box int and a box string. It was exactly the same, but it's much cleaner. You can also define multiple generic parameters, like box, kv, and use them the same way. Next, we demonstrate generic constraint. Let's create an abstract class animal, then a subclass dog. Now we define a generic class animal box. If we try to pass a string, we will get a compile time error, since string doesn't extend animal. Now onto strings. A string can be thought of as a water pipe. Data flow through it over time. We define a string controller and a string subscription, then start a timer that generates a random integer every second and add it to the controller. The subscription listens to this screen and print new data as it read. After 5 seconds, we close the controller, subscription, and the timer. Let's run this works. Now that we understand string and generic, we will refactor the previous container page to use a string instead of setState directly. We create a new page, string container page. Layout stays the same. We copy the string controller and the subscription logic. Initialize the subscription in state and use setState inside the listener to update the UI. In dispose, we clean up everything. Now instead of directly changing the count, we add a value to the string. Let's run it. Works perfectly. Also, this feels more complex. It's a stepping stone to splitting logic into a proper block structure. Episode 3. Now let's extract the string logic from the page and move it into a block class. We create page 3 by copying the layout from page 2. Let's we create a container block class and move the controller into it. We add a getter to import the string and define a new controller state class to replace the previous int, preparing for more complex data in the future. Then we move increment and decrement method into the BLoC class. Everything still works. Now we create a builder widget to extract the subscription logic. This is a stateful widget that wraps the text widget we want to rebuild. You take in a BLoC and a builder function to return the update UI. We also move the subscription logic into this builder. On the page, we replace the old text widget with a new builder and use the state path to update the display. Let's run it. What's the same? Episode 4. Now let's lift the BLoC on the top level and pass it down via content. We create page 4 and copy everything from before. Let's take a look at how the official BLoC package handles this. In pub/spec yum, we can see the user provider package. If we dive into the source code, we will see that provider is a stateless widget that uses inherited provider to pass the BLoC down. We will follow the same pattern. First, add the provider package to our project. Then create a custom BLoC provider with a generic tag t10 container block. Create a function and dispose of the BLoC by calling its close method. So we can now remove the bulk dispose from the page. On the page, we no longer manually create or dispose the BLoC. We just use context read to retrieve it. Sum for our builder now is read the BLoC from the content. Don't forget to wrap the widget tree in BLoC provider. Let's run it, it still works. Episode 5. Let's wrap this up with a final round of abstraction using generic and event. We copy everything into page 5. First, we define an abstract class BLoC and move all controller logic into it. Controller block now returns BLoC. We import the controller and add an emit method to update the state. Now let's update the provider and builder to use generic. The provider becomes BLoC provider, and the builder becomes BLoC builder. This let the builder access the block state. Now let's hand event like the optional BLoC does. We define a base container event class and a specific event like increment event and decrement event. In container BLoC, we add a method that handle different events accordingly. We remove the old increment and decrement method on the page. We now use BLoC add to trigger update. Let's run it. Works the same. And there you have it, a simplified version of a BLoC framework built from scratch. The structure and the flow are nearly identical to the optional BLoC package. That's it for this episode. I'm currently looking for a Flutter related job opportunities. If you have any leads, feel free to reach out. Thanks for watching, and I will see you in the next one.